Hi, my name is Roman and today I will show you how to use Web-PDB remote debugger to debug Python add-ons for Kodi Media Center. There are several options for debugging Python add-ons for Kodi. For example, integrated developer pair environments like Visual Studio or other Python tools for Visual Studio or Eclipse with PyDev plugin or JetBrains PyCharm. All they provide remote debugging options, but all of them have their disadvantages. First, you have to use a specific integrated development environment, which is not convenient if you are using some other tools or simple text editors like Sublime Text or Notepad++. And second, all those debuggers, they do not work well inside Kodi because they open, for example, they open blocking sockets to listen for incoming client connections, and those blocking sockets, for example, prevent Kodi from shutting down correctly. For example, if you want to exit from Kodi, those blocking sockets prevent you from doing this. And for example, on Windows, Kodi process will simply hang, and you have to use a task manager to terminate this Kodi process. And if you take my favorite Python integrated development environment, which is JetBrains PyCharm, it has a remote debugger only in its paid version, and a free community edition simply doesn't have a remote debugger. There are other standalone remote debuggers for Python, but they also have the same disadvantages. All they use blocking sockets which are not closed correctly inside Kodi, unfortunately. Were not simply made to work inside Kodi. So I have created a Web-PDB debugger, which actually is not a new program and new software, but this is simply a web interface for Python's own built-in debugger, PDB or Python debugger. The Python standard library includes a console-based debugger, PDB, but unfortunately you cannot use it from Kodi because Python interpreter in Kodi does not have a console. Standard input and error streams are redirected to the Kodi log, and the standard input stream simply does not exist. If I'm not mistaken, it's a fatal error to try to use the standard input stream from a Python add-on inside Kodi. So Web-PDB debugger provides emulate those standard input-output error streams for Python built-in PDB debugger, and allows to debug Python add-ons remotely using a web browser. Okay, the Web-PDB debugger exists in two versions. First, it's a general Python package, which is available on PyP or Python Package Index and can be installed using Python's pip package manager. It's compatible both with Python 2 and 3, and the second version is actually a library add-on for Kodi, which is available in the Kodi official add-on repository in program add-ons section. It's not a program add-ons, but it's not a program add-on, but it is I'm made it such way that it is listed on the program add-ons section because you cannot install. Unfortunately, for some reason, you cannot install library add-ons manually. So I added a program add-on record in this add-ons add-on XML metadata file, so it can be installed manually from the Kodi official repository. So let me show how to do this. Let's open Kodi. I am using Kodi 17.1 version, which is Krypton version, Kodi Krypton, and see installed from repository, Kodi add-on repository, which is the official Kodi add-on repository, program add-ons. Let's scroll down, and here we have Web-PDB add-on. It is already installed in my Kodi instance, and if you try to run it, it shows this simple information dialog and does nothing else. Because it's actually a library add-on which provides a debugger. Let's return back to our add-ons section, and I will show how to debug a Python add-on using Kodi Web-PDB remote debugger. Some time ago, I created an example video plugin as a tutorial plugin for beginner add-on developers. It is available in my GitHub repository, and now I will use this example video plugin to demonstrate how to use a Web-PDB debugger. Okay, first let's switch to our here the code for the source code of my video example plugin, and to use Web-PDB debugger, first you need to add it to your add-on XML metadata file as a dependency. Otherwise, you won't be able to import Web-PDB debugger module. And so you see that I already added the necessary line to the add-on XML file, and you can do the same. And here the main script of my video example plugin, and to add the debugger, to attach the debugger to your Python script, your Python add-on, you need to add this line to your add-on. Import Web-PDB semicolon Web-PDB set trace. As you can see, you actually can Python actually also supports semicolon as a command separator, although it is discouraged by Python's style guide PEP8. However, it is more convenient to have this debugger call in one line, because you can quickly to turn it on and off simply by commenting it. For example, in PyCharm, you can press Ctrl/ and you can comment this line, and your add-on will work normally, and you can uncomment this line, and your add-on will be you will your add-on will have the debugger attached to it, and you can debug your code with the debugger. Okay, let's show how it works. Now I will start my example Kodi video plugin with the debugger, which already have the necessary debugger line, and I click it, and you see this is an information, a small label, and it's actually a progress dialog, background progress dialog, which shows that Web-PDB debugger sessions is active, and that the web interface is available at this address. This is actually a network address of my computer. However, if you accessing the debugger from the same machine, you can simply use a local host address, which I will do now. I will switch to my browser and type localhost. I already have it. It's after completion already added necessary address for me, and localhost colon 5555. Okay, enter, and now you see the web interface of Web-PDB debugger. The web interface has several elements, windows. First, it's a source code window where I can see the source of the source code of the Python script that is being debugged, and we see where our execution stopped. And at this moment, the execution of our video plugin is suspended, and PDB debugger waits for our input, for your command. You see globals. Globals window shows your global variables, and locals window shows your local variables. Now we are at top level, at module level, so global and local scope, our scopes are the same, so the contents of globals and locals window are the same. Also, we have a quick commands toolbar with the several buttons for most common debugging commands, and also a quick help dialog where you can see some brief information about how to use PDB debugger. Also, and In the lower half of the interface, we have our PDB console. This will PDB console windows show our command debugger command history and their output of those commands. And here we have a text field for entering debugger command. We have a send button which to send commands to the PDB debugger, and you can also press enter to send debugger commands. Let's see how the debugger works. Next command, or simply n, allows you to execute your Python code line by line. So let's see how it works. I type n, enter, and our script proceeds to the next line. As you see, only real code lines are taken into account, and comments are skipped, which is very convenient. Also, our quick commands toolbar have a button for this command. We can press it, and it also sends the same n command, and we can execute our Python code, always staying at the same level. The peculiarity of the next command is that you always stay at the same level. You don't enter function calls, unlike the next command which I want to introduce, which is a step command, or simply S. S command also allows to execute your Python code line by line, but unlike next command, it enters into lower level Python function, into your function calls, and which is not always desired, because it's not always wanted, because you may accidentally step into some third-party library or from the standard library function which you do not want to debug. So if return from this, if you stepped into a function to return from a function, you can use a return or error command, because we're now at the module level. The return command won't work, but later I will show how it works. So if you accidentally stepped into some function, then you can hit press enter error command, and you will be moved to your exit point, and then the next return command will return you to the previous level. And as I said, both next and step commands allow you to execute your Python code step by line by line, but next command with next command you always stay at the same level, and with step or step in command you can step into function calls. However, executing your Python your add-on line by line can be time consuming, so you can set breakpoints to stop only at interesting point, at points that actually interest you, but not by just executing it line by line. So let's see how to set a breakpoint with Web-PDB debugger. Uh, Web-PDB web interface actually allows you to set breakpoints by clicking at line numbers in Kodi in code window. Let's click at a line number, and you see that the line number now changes color to red. It means that we set our breakpoint. And now I will introduce you our next debugger command, which is continue command, or C, simply C, where we C command with after C command your Python code will continue to execute until to the very end, or until to the next breakpoint, if you have any breakpoints. And actually at our quick command to toolbar we have a special button for this continue command, and let's press this button, and now you see that we moved to our breakpoint, which is a router function call. Now I will show you how step command actually work. Let's because if I enter next command, at this moment our script, our addon will end at this point, because it's actually the last line of our main script. But with step command, or if I here actually I have two dedicated buttons for step and return commands at our quick command toolbar. So if I press the corresponding button, which I will enter into lower level function, into our router function. And now you see that the content of globals and locals windows have changed. Now those contents are different, because we now entered into a function, and globals window show our global variables, and locals window shows our local scope, or our router function scope. Let's move to the next line, and you see how the content of locals window change as new variables are initialized. Also, the next useful debugger commands are print, or P, and pretty print. They do the same. They print the value of some variable, or a result of some Python expression, but print command simply prints it in one line of the result, and pretty print command, or PP, tries to print the result with pretty formatting, which is useful when you are printing Python lists and dictionaries. Let's print our global videos variable, p videos. Okay, you see that the value of the videos, our global videos variable, is printed in one line, which is not one long line, which is not very convenient. So, and let's see how pretty print command works. By the way, you can access your debugger command history by pressing arrows up and down, and arrow up scrolls through the list of previous commands. Let's change pp, p to pp, and pp videos, enter, and you see now our Python dictionary is printed with more convenient formatting, and you can actually it's more convenient to analyze its contents. The next command I want to demonstrate you is an exclamation mark command. It's literally an exclamation mark. Let me type it. The exclamation mark command allows you to execute any Python command or function or statement or expression in the current context. The result of this statement or expression will be printed in PDB console window. But it's very much like print or pretty print command, but print command prints only works only with variables or expression that actually produce some values that can be printed, while exclamation mark can execute any Python command or function or statement, for example, in-process statement and such, which actually is very useful when you're analyzing your Python program, Python add-on runtime state. And in case of Kodi add-ons, it is also very convenient, especially very convenient, because using this exclamation mark command or print command for that matter, you can access actually access other Kodi APIs or programmer interfaces like info labels or JSON RPC interface, and to see which values and which result they produce. For example, let's see the value of system build version info label. Let's exclamation mark xbmc dot get info label. Enter, and now we see the exact build version of my Kodi instance, which is 17.1, and git the data and the hash from git repository. Okay. And let's set another breakpoint in lower level function. Okay, let's set a breakpoint here, and where I enter, I can press the continue button or enter C command, and I will move to this the next breakpoint. And now I will show you the next debugger commands, which are up and down commands, or simply U and D, and or arrows up and arrows down on our quick commands toolbar, which allow us to navigate, to move up and down in our call stack or execution stack. Move to lower or upper execution frame. You see, in the Python interpreter, an execution frame is a minimal execution unit, which roughly, not roughly, but actually corresponds to a scope. If you know your Python, you know about global and local scopes, and an execution frame in a Python interpreter actually correspond to this scope. For example, the module level or top level execution frame correspond to global scope, and if your module calls some function, an interpreter creates a lower level execution frame, which is linked to upper level, your module level execution frame, and if this function calls another function, the Python interpreter creates a lower level execution frame, which is linked to your parent frame, and which in its turn is linked to its parent frame. And the Python interpreter stores the list of those frames, which is called call stack or execution stack. And if, for example, if an exception, an unhandled exception happens during execution of your Python code, then Python interpreter unwinds all this call frame stack and prints your so-called stack trace, or the sequence of calls, or which actually led you to this point where an exception happened. Let's see how we can navigate our stack frame to upper frame, and you see that we returned to the previous function, which is a router function, and we can up, and you see we have returned to our module level, and we can now, which is our top level frame, and we there are no top level frame here, so we can only move downwards, so down and down again, and here we returned to our breakpoint. And also another useful command is a where command, or simply W, which prints our call stack or frame stack, which allows you to see where we are, and the sequence of calls that brought us here to this point. And at our toolbar, this is this button corresponds to W command, where command. Again, we printed our stack trace. Now, if you want to continue execution of our add-on, you can enter a continue command, a C command, hit this button, or you can, if you do not want to continue execution of your add-on, you can use our next debugger command, which is quit, or simply Q command, which terminates our Python program, or Kodi Python add-on in our case, actually it raises a special PDB quit exception and abnormally terminates your Python program or your Python add-on. Let's enter this command. OK, and you see that Kodi shows an error message because our Web-PDB debugger, or rather PDB debugger, raised an exception, PDB quit exception, which terminated our add-on. The Web-PDB debugger also offers you a special catch post-mortem function, which is actually a context manager. If you don't know what a context manager is, I recommend you to read some Python books, but in brief, a context manager is a special Python construction, Python object that allows controls its execution block, its scope, and execute some actions when leaving this execution block or scope. And in our case, our catch postmortem function or context manager actually allows us to catch any unhandled exception within its control block, the block which this context manager controls, and to start post-mortem debugger sessions. This is if in case of any unhandled exceptions within your Python add-on. Let's see how it works. Now I will comment this our set trace call and add our sketch postmortem context manager. You can add it at any point at any place of your Python program, Python script, your add-on, but it's I will wrap the router function call, which is the entry point of my example video plugin, so it will catch any exceptions that happen within my example video plugin. Import Web-PDB and with a Python statement which introduces a context manager, Web-PDB post Okay. My example video plugin is tried and tested, and it doesn't have any errors. So let me introduce one, which I will added this raise artificial error condition, which is runtime error exception, raise runtime error, and which will model our actual Python error. And let's see how our catch postmortem context manager works. Let's start our example plugin again. Okay. You see the error message, and again we see the message that our debugger session is active, and if we reload our browser tab, we'll see that our Web-PDB debugger has entered into post-mortem debugger, started a post-mortem debugger session. The post-mortem debugging is different from live debugging because it's called post-mortem because at this point your Python program, your Python addon is effectively dead, and you are doing a post-mortem analysis of it, basically an autopsy of your addon. So next and step command do not work because you cannot execute that program. You can only use print and exclamation mark statements to examine the state of your Python program prior to unhandled exception, or you can navigate your frame stack up and down, but nothing more. As I said, it's a post-mortem debugging, and you can only examine this state of your addon, but not execute it. This is all for today. My name is Roman, and today I showed you how to use my Web-PDB Python debugger to debug addons for Kodi Media Center. Bye bye.